Hello again. This is the second video of the exercises from this week's long day. And in the first video, I did some hand calculations or computations of exercise 1 and 4, and now I will go through exercise 5 in a Maple version. And I think this is an important exercise because here in practice you will demonstrate a verification of the Gauss's theorem. And you're given a vector field and you're given a spatial field. And this is, as you can see it, it's part of a spherical, of a sphere. It's a hemisphere. You see z is greater than 0, so it's a hemisphere with radius a. And what we want to determine is the flux outside the bounding surface of this hemisphere. And in order to do so, we use the Gaussian theorem that says that this flux is equal to the volume integral or the spatial integral of the divergence. And we do this, first of all, we initialize and then we enter, so you get the vector field, and then we go on to implement parametric representation of this hemisphere, and then we state the Jacobian for such an hemisphere, and this is given by this formula, and then we compute the divergence of this vector field. We turn the divergence into a function by using the unapply command, and then we do the restriction of the divergence to our parametric representation of the hemisphere. So, and this is given like this, and then we integrate this divergence multiplied by the Jacobi function, and we integrate from 0 to a, and from 0 to pi half, and then finally from minus pi to pi, and this will be the hemisphere. So let's see what the result is. Like this. Now we want to show you that this is actually equal to the direct computation of the flux, and we do a parametrization, and you see here we have the result here in the text, and what we do now is that we enter a parametric representation of the hemisphere. Then we compute the cross product of the tangent vectors to the hemisphere, and we get this result. And if we then take the dot product between our vector field restricted to the surface of the hemisphere with this normal vector, we get this value for the integrand, and then we can evaluate the flux through this, and this is, you see, this is actually equal to the result we have up here. But let's compute compute the flux through the circular disk at the bottom of the hemisphere. So I'll make a parametric representation of this. Take the normal vector in the usual fashion, and then we compute again the flux integrand, which is a dot product between the restriction of the vector field to this parametric representation here and the normal vector. And this flux integrand is 0, and therefore the total flux is equal to the flux through the hemispherical surface. Now we want to know when this flux is positive and when it is negative. In order to do so, we put it equal to 0 and solve for A, and you see you get A is a positive quantity. So, and then we plot, and we can see that when 0, or when A is between 0 and the square root of 30 divided by 3, the flux is negative. Otherwise, it is positive. And this is what I have chosen to show you of this program. Please study the Gaussian theorem or Gauss's theorem in detail, and okay, good luck. Thank you.